This is our introduction to exercise 3F on finding side lengths. Over the last couple of lessons, we've talked about Pythagoras' theorem and how it's related to trigonometry. We know that in Pythagoras' theorem, it's to do with the side lengths of the triangle, right? The outside measurements. If you have two of them, you can find the third one. Easy. Trigonometry says that if we have one of the side lengths and also an angle on the inside of a triangle, we can find any other length. That's all it's saying. Okay, so Pythagoras' theorem has nothing to do with angles as long as it's a 90-degree angle, whereas trigonometry wants one of the angles. Okay, in order for this calculation to work, just double check that your calculator is in degree mode. Right? If you've got a calculator with you, just make sure, and it shouldn't have changed between now and then, but make sure that your calculator has a DEG at the top or like a symbol for D. Up to you. Depends on your calculator. Right? But if you're getting drastically different answers, for example, the answer is 80 degrees, and your answer is, let's say the answer is 15 centimeters, and you get 1.6 centimeters, then obviously it probably is a calculator issue. Okay, so we talked about last lesson about sine, cosine, tan, and how to identify which one to use. Remember the ratios, right? We're using the idea of similar triangles, so they're just ratios. So if we have the angle and one side length, we can find the rest of them. But let's start by looking at how to find it in our calculator. Let's use sine 70 as an example. Sine 70 degrees. All you need to do in your calculator is you open up your calculator, you press the button that says sine. It may automatically open up a bracket for you, it should, and then type in 70. Because your calculator is already set in degrees, you don't need to type in the degree symbol. You can just close the bracket. Last lesson I mentioned that technically you don't actually need to close the bracket and it'll still give you an answer. But it's very important that we close the bracket because, as a habit, if let's say we're typing in sine 70 times it by 5, that would give us an answer of 4.67. However, if we forget the bracket, it's going to read that as sine 70 times 5, which is sine of 350, and give us negative 1.7, right? So it needs to make sure that we've got the bracket there. So in our case, we're going to go ahead and put our brackets in. And we end up with 0.9. I'm going to round it to two decimal places. Does that round to 9.4 or 9.3? 9.4, thank you very much. 0.94. I'm going to use the approximate symbol that we learnt last lesson. 0.94. Any questions? Okay, let's move on to sine 40 equals x over 5. Now, before I put anything in the calculator, right? Because I know if I put sine 40 in the calculator, it's going to get a really gross long decimal, right? Let's deal with that later. The only thing stopping x over 5 from being just x, which is what we want, is that divided by 5, correct? Hayden, do you agree? So what's the opposite of divided by 5? Times it by 5, right? And if I do it to the right, thank you very much. I heard someone whisper it under their breath. Times it by 5 on both sides. So I'll get sine of 40. Just out of habit, I'm going to write down the degrees, and I really recommend you do so as well. Times it by 5, which equals, and you'll see on this side, because we've got divided by 5 and times by 5, they cancel out, don't they? And we're left with just x. Any qualms, queries, questions? Okay. So then I just put that in the calculator. So I go sine of 40 times it by 5. What's wrong with this? Thank you very much. It needs a bracket. So we have to make sure sine of 40 times it by 5, just like we wrote it in, gives us an answer of 3.23. Again, I'm going to use my approximate symbol to get 3.23. Great, okay, so we put stuff in the calculator, but let's give meaning to what that stuff is. Hopefully by this stage you've copied down the diagrams for the triangles. It says for each triangle find the value of x correct to two decimal places. Does anyone remember what is the first step when it comes to solving trigonometry questions? What is the first step?
Finding the adjacent.
Perfect. Finding our adjacent opposite hypotenuse. Now we know hypotenuse is the easiest one. Hypotenuse is just going to be the one that's on the longest side, or the one that's opposite to the right angle. Rose, which one is the adjacent? Is it the x or the 30 or this side? It's underneath. Thank you very much. And of course, the opposite's on this side. Remember, the adjacent is the one touching the angle that we're focusing on. So now, I know that I'm using hypotenuse, and I'm using my opposite. There is no number, no letter, we're not even looking at the adjacent, so we're going to ignore that. I'm going to refer back to mine, hopefully you've got this in your notes, my SOHCAHTOR. If you don't have it in the page, I'd highly recommend you write it down. Okay, SOHCAHTOR. And then, well, I know that it's O and H, so I'm going to look at using my sine. So sine of 32 degrees. Now you would have written theta before. Now we have an angle, we're writing 32 degrees. Which equals to my opposite. My opposite in this case is x over my hypotenuse, which is going to equal to 4. You see how this is very similar to the last question we did in terms of format? So now I do the same thing. I've got the only thing stopping my x divided by 4 being an x by itself is that divided by 4. To get rid of that pesky divided by 4, I do the opposite and times by 4. And again, Hayden, if I do it to the right, thank you very much, do it to the left. And so I'm going to end up with sine of 32 degrees times 4 equals 2. And again, these two cancel out. And so that gives me just x. I'm going to go ahead and put that in my calculator. I press the sine button, and I just want to give you a heads up, be very careful not to accidentally get this one instead. This one is sine -1. It's actually sine to the power of -1, or sine inverse. You'll get that if you press your shift or your second or whatever it's called in your calculator button, and then the sine button. So make sure it doesn't come with that, or you get a drastically different answer. So sine 32, remembering to close the bracket, and then we times it by 4. Gives us an answer of 2 and I'm going to round to 2 decimal places, 2.12. So x is approximately 2.12. If I look at my triangle, Oscar, does 2.12 look about right for x when 4 is the longest side? Yeah, it looks about right to me. If I got 5 on x, how do I know that's wrong? Thank you very much. 4 must be, because that's the hypotenuse, must be the longest. If you get 5, that's bigger than 4, you've done something wrong. Let's go through the second example a little bit quicker, since we're all familiar with the process now. Okay. So, let's say I am trying to get this one. Again, Christos, do you remember what the first step of trigonometry is? Thank you very much. The adjacent, now I'm going to again start with just labeling hypotenuse because I think that's the easiest. Hypotenuse is on the longest side or the opposite of my right angle. The adjacent is the one that's touching the angle, and the opposite is on the, of course, opposite of that side. Brody, which one of these, A, O, or H, do I care about? O. O? You mean that's the one I don't care about, right? What? Because that doesn't have anything there. Yeah. Yeah? I think you just misheard me. The H and the A is the one that we do care about. The O we don't in this case because there's nothing next to the O. So I look back to my diagram and I think, okay, which one has A and H? It's clearly the middle one. Yeah. So I'm going to write cosine of 26 degrees equals to adjacent over hypotenuse, so it's x over 5. Oscar, what do I do next? Perfect. I'm going to times by 5 on both sides. On the left-hand side, I get cosine of 26 degrees. Times it by 5. On the right-hand side, we just get x. Am I going too quickly? Am I going too slowly? Okay, thank you to no one for responding. I put that in my calculator. Cosine of 26 times it by 5. Again, please don't forget your brackets. Go back and put in your brackets there. So cosine of 26, close your bracket, times 5, gives you 4.49. So x is approximately 4.49. Does that look about right? Rose, does that look right? 4.49? If it looks a bit weird. Like, it's technically correct, but it looks a bit weird, doesn't it? Because to me, the adjacent side, visually, gentlemen, thank you. The adjacent side visually looks quite similar to the opposite side, doesn't it? Yeah? And they can't both be almost 5. That doesn't make sense. You can see how the angle of 26 degrees, that doesn't look like 26 to me. It looks more like 40 degrees. It's not to scale. Some of you thought, why don't I just get a ruler and a protractor and figure it out? It's not to scale, right? You can't just use that. Any questions? Okay.